Hi, guys. So today we're going to talk about glazing, what a glaze is, and some things that happen during the firing, and some things that we don't want to happen. So, to start off, a glaze is a combination of silica, alumina, flux, and some other materials put together with water that, when fired, creates a glossy glass coating on the outside of the piece. That makes it waterproof so that we can put flowers in vases and coffee in cups. And it also makes it beautiful, depending on whether or not we want things to be shiny or matte or blue or green. All glazes have an ideal temperature at which to be fired, and that's going to be the temperature where they melt without running off the side of the piece. So in the kiln, we heat this material up and it melts and it becomes fluid on the surface of, in this case, let's say those cups. If we keep it at that temperature for too long while it's fluid, it'll just run down the side of the piece. So we try to hit that temperature and then immediately or almost immediately start cooling the kiln down so that before that glass runs down the side of your piece and forms a puddle on the kiln shelf, it starts to solidify again. Um, and that temperature is called the maturation point. So, maturity is the temperature at which the desired glaze effect is achieved, generally, when a glaze is fully melted and glassy on the surface. What does each part of a glaze do? Oh boy. Well, the alumina. The alumina is the clay part of a glaze. So it has glass there, right? And we'll talk about that. But if it was just glass, it wouldn't want to bond with the clay. So the alumina is the clay part of the glaze, which helps the glaze adhere to the pot, and it adds other aspects to the glaze like viscosity and or durability. But think of it as the glue, the thing that makes it stick to the pot. The silica, or flint, it's also referred to, is the glass maker of the glaze. The higher the silica content in a glaze, typically, there are variations, but typically, the shinier the surface of the glaze will be. The silica, however, it melts at a really hot temperature. So, in order to make the silica melt at a more reasonable temperature, we add some other materials to the glaze. Those are called fluxes. So, typically they're oxides, but they can be other things. And they lower the melting point of the silica so that we don't have to achieve those super high temperatures in order to get a good looking glaze. And if we have those three aspects, we have a clear glaze. So we then add something called a colorant to the glaze, which is either an oxide or a stain. And we'll talk about the difference between those two things in a second. And that tints the glaze or gives it its color. So if you want a blue glaze, you might put in something like cobalt or a blue stain. There are some companies out there that create this stuff for you. Um, and not just in a bottle. You can buy it in a powdered format so you can get like a clear glaze and then add your own colorants to it. And those compounds are what we refer to as frits. And if we don't have a glass maker in a glaze, then that is called an engobe or an underglaze. So it's a glaze that is not shiny. Oxides and stains. Okay, so we have our clear glaze, we add something to it. Um, it might look like the color we want it to look like, or it might not. If we're adding an oxide to a glaze, that's an inorganic metallic material element that we add to the glaze, and when it melts chemically, it combines with some other parts of the glaze and it changes colors, and that's kind of the magic part. So cobalt oxide is black when we put it into a glaze. It can also be kind of a purple color, which is very pretty. But when it comes out, almost always that just like bright, deep USA American blue. Uh, so oxides change color in a glaze during the firing process. Stains, on the other hand, are previously fired materials that are introduced to the glaze as a colorant. But because these have already been fired, the results are very, very, very predictable. They've already gone through the firing process. So imagine taking a piece, glazing it blue with an oxide, firing that, then crushing it into a million little teeny small pieces and putting the blue stuff that used to be the blue pot into a glaze. That's what a stain is. Not sure why my words don't fit on the screen there, but we're going to keep going. Hopefully that won't be that big a deal. Calcining. Um, Calcining is firing materials before they are added to a glaze. So when you fire things, they shrink, right? So if we put things into the glaze that haven't shrunk yet, sometimes that can create what we call glaze defects, and make our results a little less predictable. So oftentimes we might take something like a clay that we're going to add an alumina part of our glaze and fire it ahead of time. And then when you add it in, it's already shrunk. So it by itself won't change the surface, let's say, of a glaze. Oxidation and reduction firing. Look at this guy, right? He's throwing wood in there. This is a wood firing, and he's going to do something that changes the look of his pieces that has nothing to do with anything that he's put into the glaze. So, how you fire can determine whether or not you get a blue, a green, a red, different kinds of color. The inside of the kiln, or what we call the kiln chamber, either has a lot of oxygen flowing through it or it does not. Now, in our case, because we don't have an open flame, there isn't oxygen moving through the kiln. But outdoors, if we had a gas firing kiln, we would want to encourage oxygen to flow through the kiln and the kiln chamber to keep that flame burning, keep the material burning and raise the temperature on the inside of the kiln. Um, if we just continue to let that oxygen flow in there, that's an oxidation environment. However, if for let's say 15 minutes we decide to or close off a damper inside the kiln so that oxygen can't flow through the kiln, air can't flow through the kiln anymore, that flame wants to stay alive. So it's searching for oxygen wherever it can find it. And where it finds it is in the materials in the glaze. It steals it from the glaze. And when it does that, the results change in terms of the way that the glazes look. Things that have copper in them, for example, go from being a green color when they come out of the kiln to a red color. Um, but it has to be the kind of kiln that has some kind of air flowing through it. But a simple example would be this, which is a pit firing where we start the flames and then we cover it up with dirt. You've seen this in Ceramics 1, in videos about Maria Martinez, but they bury the stuff once the heat is there, and that smothers it, and therefore no air is moving through there, and you get a black color on the color of the clay. All right, on to glaze defects, things we want to avoid. Sometimes due to the application of the glaze, the formation of the glaze, the chemical, the recipe, like when you're putting it together, or how quickly or how slowly you heat up the kiln, a glaze can have a defect, and a glaze defect, therefore, is an unintended outcome, something that we don't want to see happen in our finished pieces. Okay. So what are some of them? Like these clumps or little holes in there or cracks. Okay? None of these things are the kinds of things that we intend to have happen. Or if you were manufacturing a glaze to go into commercial production, that you would want to see happen on there. Now, a lot of artists nowadays intentionally try to create some of these things for their artistic effect. Like this might not be good for trying to like clean your plate after you've eaten spaghetti or something like that. It'd be hard to get into all these little cracks. And over time, if there's these cracks in the surface of a glaze, the coffee that you drink will soak into the glaze body itself and discolor everything there. And this doesn't feel good when you pick it up and that sort of thing. But then, if it's just to be looked at, some people, think, hey, it's kind of cool. But what are they? Crazing is a glaze that shrinks more than the pot. So the pot shrinks and the glaze shrinks and the pot stops shrinking and the glaze keeps shrinking. And as it shrinks more, it cracks, it fractures, it can't cover the surface of the pot anymore. Now, those cracks can then be stained like they are here, and they can be quite beautiful, like a spider web on the outside. But again, if you're washing dishes or if you want this thing to last, it's functional where you don't want crazy. Are you crazy? Crawling. Crawling can be your fault. It can be the manufacturer's fault. Um, and the next one can be kind of my fault. But crawling typically happens if you put glaze onto a dusty surface. The glaze bonds to the little particles of dust and creates these little clumps or droplets. It can also be from just applying the glaze way too thick, you know, uh, lay on there, and you kind of know it before you put it in the kiln. Um, or it could be like Mr. Walter put too much clay alumina content into his recipe. Yeah, and that can make them want to clump together because they're finding the clay in there and trying to like form a little ball around that clay. Shivering is the opposite of crazing. If the glaze doesn't shrink as much or as quickly as the pot shrinks during the cooling process, it forms like this shell that's got a little gap between the glaze and the pot because the glaze stopped shrinking and the pot continued to, or the pot shrank too fast and the glaze was kind of like hanging in there and became this kind of like the gap between the two surfaces. So when you pick it up, you can feel it, like it's like, oh, this glaze is kind of like not sticking to the outside. It's going to flake right off. That's a real problem because, your glaze falls off your pot, and it can be sharp and, cut people and things like that. But shivering is too much shrinking or too little shrinking. And then pinholing is typically because the kiln has been fired too quickly, and the glaze didn't have a chance to sort of like boil, maybe, like on the surface, or it boils because it's being heated so fastly, it doesn't melt evenly, and then it cools down. So if you're in a big hurry, you're probably going to get pinholes. You gotta follow like the rules and go at the right speed in order to get the right effects. But those are some things that go wrong with glazes. What are some glazes that we all have loved? And we use variations of these glazes ourselves, although um, they're named mostly to like remind you of a color of a glaze in the future. Celadon is a very famous green semi-transparent glaze that was developed, we think, in China, and then improved, and it's probably most famous for its use by Korean potters. And you can see here an example of one kind of celadon. There are many kinds of celadons, but this blue to blue-green color, and then how it pools in some areas and goes darker. That is a celadon look, although there are many kinds of celadon. Sheena is another one we mentioned, and you can see this kind of orange, and that becomes kind of this white, thick color. One of my favorite glazes. And it was developed in Japan during the Momoyama period. Loves Momoyama. Love saying that. And then the recipe was kind of lost. It was replaced by other glazes and then redeveloped during the 1970s. So when I was growing up learning about pottery, it was a big deal to have Shino glazes, and that's probably why I liked it so much. So anyway, those are a couple of famous glazes. Um, we will also talk in class about how to best apply glaze to your piece. But that's enough for now. So I'm going to sign off. See you in class.